Good morning, sir. This is Sumant from EC department. Today's my topic is about Yagiuda antennas. Now, introduction to Yagiuda antennas. Yagiuda antennas are directional antennas commonly used in radio and television reception. They were invented in Japan in 1926 by Hitsuki Yagi and Shinataro Yuda. These antennas are valued for their high gain and directivity, making them ideal for long distance communication. Basic components of a Yagi-Uda antenna. The main components include a driven element, reflector, and one or more directors. The driven element is typically a dipole connected to the transmission line. Reflectors and directors are passive elements that help focus the signal in the specific direction. How Yagi-Uda antenna works. The antenna's elements are arranged so that they interact constructively to amplify the signal in one direction. The reflector behind the driven element reflects signal forward, increasing gain. Directors in front of the driven element help focus the beam, improving directivity and range. The antenna's elements are arranged so that they interact constructively to amplify the signal in one direction. The reflector behind the driven element reflects signal forward, increasing gain. Directors in front of driven element help focus the beam, improving directivity and range. Design parameters of Yagi-Uda antenna. The length of each element and their spacing are critical for optimal performance. The boom length refers to the total length of the antenna structure holding the elements. The number of elements affected the gain and directivity, with more elements generally providing higher gain. The Agibuda holds the structure of the element, and the boom length is very small compared to all all elements. Advantages of Yagiuda antenna. In these Yagiuda antennas, it offers high gain and directivity, which enhance the signal strength over long distances. Yagiuda antennas are relatively simple and cost effective to manufacture and install. Their directional nature helps reduce interference from unwanted signals and noise. It is also used for television signal and dish box signals. Limitations of Yagiuda antenna. They have a narrow bandwidth, limiting their effectiveness across width frequency ranges. Precise alignment in necessary for optimal performances, which can be challenging in some environments. They also have a narrow width and limiting their effectiveness across wide frequency range. Their size can become impractical for very high frequency applications. Precise alignment is necessary for optimal performance, which can be challenging in some environments. Common applications of Yagiuda antenna. They are widely used in amateur radio, television reception, and point to point communication. Yagiuda antenna are employed in radar systems and wireless networking where high gain is needed. They are also used in scientific research such as radio astronomy and atmospheric studios, and also in past our ISRO satellite communication also. Installing and maintaining Yagiuda antennas. Proper placement at a high location enhance signal reception and transmission. Regular inspection and tuning ensure the antenna maintains optimal performance. Using Rotator allows for precision aiming of a antenna towards the signal source. Future trend and innovations. Advances and focusing on broadband Yagi designed to cover wider frequency ranges. Integration with modern material can improve durability and performance. Research continues the multi-elements arrays for the high gain and better beam shaping. Summary and key takeaways. Yagiuda antennas are a highly effective directional antennas with a simple design. Their high gain and directivity makes them suitable for various long distance communication needs. Proper design, installation, and maintenance are essential for optimal antenna performances. Thank you, sir.